Hi folks, this is Calc 2 Take Home Assignment 5. We're asked to find an improper integral and then find an indefinite integral, and then asked to find its corresponding improper integral. And so we start off, I want to find the integral e to the negative st cosine t dt. If we follow the usual rules of thumb for integration by parts, we're going to let u be the cosine of t, and that means that the du is minus sine of t dt, and we're going to let v then be everything else for dv. So then when we integrate, remember s is a constant, so we get minus e to the minus st over s for that. And so integration by parts says that our integral is equal to uv minus the integral v du. So it's going to be minus e to the negative st cosine t over s minus the integral v du. So we have a negative times a negative is a positive. We have a 1 over s we'll bring out front. E to the minus st sine of t dt. Now we're going to examine this a little more closely. So to integrate e to the minus st sine of t dt, we'll proceed similarly. We got u is sine of t, du is cosine of t. The dv then is going to be the e to the minus st dt. So v then is negative e to the negative st over s. And so we go through the integration by parts, and we're going to get negative e to the negative st sine of t over s minus the integral v du. We have a negative, that's a positive, 1 over s times the integral e to the negative st cosine of t dt, and we're back to right where we started. But we're not, we haven't totally wasted our time, because when I feed this back in, right, we have to take this entire thing now and feed it back into here. The coefficient here is a negative 1 over s. So that's going to let us, we're going to get one of these wraparound integration by parts, and we'll be able to solve for this antiderivative by doing a little bit of algebra. Alright, so to recap now, we have the integral e to the negative st cosine t dt equals negative e to the negative st cosine t over s minus 1 over s times the integral e to the minus st sine t dt. So this is negative e to the minus st cosine t over s minus 1 over s times what we got for this guy. What we got for this guy was negative e to the minus st sine of t over s plus 1 over s times the integral e to the minus st cosine of t dt. So when I expand this out, I get negative e to the minus st cosine t over s plus e to the minus st sine of t over s squared minus 1 over s squared times the integral e to the minus st cosine of t dt. This is exactly the integral that I started with. So what I can do is I can multiply both sides by s squared, subtract and divide. So if I multiply both sides by s squared, I'm going to get s squared times the integral e to the minus st cosine t dt is equal to minus s e to the minus st cosine t plus e to the minus st sine t minus the integral e to the minus st cosine t dt. And now what I can do is I can add this antiderivative to both sides. So I have s squared of them over here. I'm adding one of them back. I get s squared plus 1 times the integral e to the minus st cosine t dt is equal to, I've got an e to the minus st I can cancel out, or factor out rather, and I've got sine t minus s cosine t. Then I can divide both sides. Well, I got that c around there. So now what I can do is I'm going to divide both sides by the s squared plus 1, and that'll give me my final answer. Okay, so this is that bottom line up there. I'm going to divide both sides by the s squared plus 1, and I finally get my answer to part A. E to the negative st cosine t dt is equal to e to the negative st sine of t minus s cosine of t, all divided by s squared plus 1. So that's part A. Part B asks us to integrate from 0 to infinity this thing. So once again, we're assuming that the s is a positive constant. And so what we mean by this is we're going to take the limit as b goes to infinity of the integral from 0 to b, e to the minus st cosine t dt. Now, here's the antiderivative. Oops, forgot my c there. Here's the antiderivative. I'm going to plug b into that, subtract off what I get when I plug 0 into that, and then I'm going to have to take the limit. Alright, so I'm going to take the limit then as b goes to infinity of, everywhere I see a t I'm going to plug in a b. So I get e to the minus sb times sine of t, or excuse me, sine of b minus s cosine of b, all divided by s squared plus 1, minus what I get when I substitute 0 in everywhere. So e to the minus s times 0, sine of 0 minus s cosine of 0 over s squared plus 1. This is the limit as b goes to infinity. I've got this thing here. I've got e to the minus sb sine b minus s e to the minus sb cosine b over s squared plus 1. And what works out here, I get a e to the 0, which is 1, 0 minus s times 1. So I get a negative s over 1 plus s over s squared plus 1. This is independent of the b. This just has s in it. So the question is, what happens here? Now, sine and cosine are bounded functions. No matter how hard they try, the sine of anything is between minus 1 and 1. Same thing with cosine. So e to the minus sb is always a positive number, and so I can go ahead and sneak this in here. I can do the same thing on the cosine. Now, as b goes to infinity, remember s is a positive number. So as b goes to infinity, this goes to 0 and this goes to 0. So we've got the squeeze theorem happening here to force that to 0. And the same thing happens over here. And so b is going to infinity and s is a positive constant. Okay, so what does that all mean? This whole thing goes to 0. And so my final answer is s over s squared plus 1. Now if you go on to differential equations, what we've actually done is we've actually computed the Laplace transform of the cosine of t. So when you get to differential equations, we've actually already done this derivation by hand. And so that'll do it for take home 5.